Okay, I want to rationalize this denominator, so that means I have to multiply by the conjugate. So I take 5, 3 minus radical 2, and the conjugate is 3 plus radical 2. I FOIL out the bottom. 9 plus 3 radical 2 minus 3 radical 2 minus 2. Up top, we have a single distribution. We have 15 plus 5 radical 2. We know the whole reason we multiply by a conjugate is to get the middle radicals to cancel out. So we have 15 plus 5 radical 2 over 9 minus 2, which is 7. Write an equation of a circle. Automatically, we should know the general formula for a circle. X minus h squared, which represents the x value of the center, y minus k squared, which represents the y value of the center, equals r squared. Well, to find that part is easy, because here's my center. So I know it is x minus a negative 3 squared plus y minus 4 squared. I just put in negative 3 and 4. Clean this up. We get x plus 3 squared plus y minus 4 squared. Now we just have to figure out the radius. Well, radius means a distance. And here's my radius right here. A radius goes from a center to a point on the circle. So now I'm going to form a right triangle. I'll drop this line down. There's my right triangle. Well, how far is this x? Well, it went over negative 3, so this distance must be 3. And how far must this be? Well, I went up 4, so that distance must be 4, giving me a 3, 4, 5 triangle, and thus r squared would be 25. And there's the equation of that circle. Solve for x. One thing I like right away is I have common denominators of x minus 3. So there's quite a few ways I can do this. I'm going to choose to multiply everybody by the common denominator. That means this one's going to get multiplied by x minus 3, this term gets multiplied by x minus 3, and this term gets multiplied by x minus 3. Numerator and denominator cancel out, leaving me 4x. Numerator and denominator cancel out, leaving 12. Sorry, I had a sneeze. And then 2 times x minus 3 leaves me 2x minus 6. When I solve this, I get 2x equals 6, x equals 3. Now most kids would circle that and go, woohoo, that's my answer. But if we check, as we're supposed to do, all our answers, we notice that if we put 3 back into that denominator, we will get 0 in the denominator. So this problem, the answer is the null set. There were no answers to this problem. This is a rejected. Okay, find to the nearest minute the angle whose measure is 3.45 radians. So I'm given radians, and I have to turn it into degrees. And I know to take radians and turn them into degrees, I multiply by 180 over pi. So my radians of 3.45 times 180 over pi, this is going to entail my calculator. Well, get rid of all this stuff. There's my calculator. .45 times 180 divided by, and I'll use my pi key, gets me 197.67. But they want it to the nearest minute, so I'm going to go into angle, which is right here in my apps, and I'm going to choose number 4. I'm going to take my answer and turn it into degrees, minutes, seconds. So my final answer is I have 197 degrees and 40 minutes. For this one, the first thing I see sticking right out is a formula. So I'm going to take that, V equals P times E to the raised to the R times T. So I've got some numbers here, 1200, I've got a rate, and I've got a time of 10 years. All right, so they should be easy to put in. A time of 10 years goes in T. My rate is 6.5%, but that means 6.5 per 100. So when I change that into a decimal, it's 0.065 because I have to move the decimal over twice. So my rate is 0.065. E is E, and P is the principal initially invested, which is 1200. And now to figure out V, I just put that all on the calculator. 1200 times, E is right here above the division sign, raised to the 0.065 times 10. So I would have, in my account after 10 years, $2,298, and then I have to round that to the nearest cent, which is 65 cents. Okay, we have a point, -3, 2. So I'm going to take a graph. I'm going to go over -3 and up 2. And there's my point. So I went over -3, I went up 2, and voila, I make a triangle because it's trigonometry. I do Pythagorean's theorem and figure out C is the square root of 13. Well, see, I did all that without even reading the problem. Well, what do they want me to do? They want me to find the cosecant of theta. Well, theta is always right there. Cosecant is sine flipped. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. My hypotenuse is radical 13, and my opposite is 2. Find the first 4 terms of the recursive sequence defined below. Well, they told me my first term is -3. So here I have my first term, my second term, my third term, my fourth term. And they told me my first term is -3. Now this says a sub n, well, I'm looking for my second term now, so I'm going to put 2 in for n, is found by taking a sub 2 minus 1 and minusing 2. I don't know what a sub 2 is. A sub 1 minus 2. Well, I do know what a sub 1 is. It's -3. So my second term is found by taking -3 and minusing 2. So my second term is -5. All right. To find my third term, a 3 minus 1 minus 3, because n now is 3. My third term is found by taking my second term and minusing 3. My third term is found by taking my second term and minusing 3. So my third term is -8. My fourth term, now n is 4. My fourth term is found by taking my third term and minusing 4. My fourth term is found by taking my third term, which is -8, and minusing 4. So my fourth term is -12. The committee has 5 members to be selected randomly. Okay, this committee, does order matter? No. So it is a combination. We've got 9 teachers and 20 students. So I'm going to pull that information out here. 9 teachers, 20 students. Determine how many different combinations can be formed if 2 members must be teachers. Oh, well, I have 9 teachers and I'm choosing 2. 3 members must be students. So I have 20 students and I'm choosing 3. The magic word "and" here means to multiply. So 9 C2, whoops, 9 C2 is 36, and 20 C, well, when he was picking 3, so 1,140, and now I'm going to multiply those together. So I have 41,040 possible combinations. Solve by completing the square. Alright, so now we got to take our steps for completing the square. First thing about completing the square says that my leading coefficient has to be a 1. So it's a 2, so I'm going to divide everybody by 2. Alright, what do I get when I divide by 2? X squared minus 6x plus 2 equals 0. Next thing I have to do is isolate my x's, which means this 2 has to come over to the other side. Now this is where I complete the square. Remember my little thought bubble over here? I take half of -6 and I square it to get 9. So I'm adding 9 onto both sides, and I've created a perfect square. X squared minus 6x plus 9 equals 7. See, this is the perfect square. The perfect square being, if I did x minus 3, squared it, this binomial equals this trinomial. And remember I told you to cheat by just taking whatever you took for half of 6? And that's the number that goes right there. Now I'm going to solve this for x, which means I have to take a square root. So x minus 3 equals plus or minus the square root of 7. Move this 3 over, and x equals 3 plus or minus radical 7. And there, I solved this. You would get the same answer if you did the quadratic formula. But they didn't want you to do the quadratic formula. They wanted you to use completing the square. So you had to do completing the square. Solve this equation algebraically. Well, I've got 4 things here. Sorry. So anytime I have 4 terms raised to the 3rd power, I know this is factor by grouping. So I'm going to group. And to group, I simply do this. I'm going to take the first 2 terms and the last 2 terms and group them. And then I do the greatest common factor to both parentheses. Okay, so the greatest common factor in this first parenthesis is 4x squared. And when I pull out a 4x squared, I'm left with 2x plus 1. In here, the greatest common factor is 9, negative, and I'm left with 2x plus 1. Hey, look what I have. I should have another common factor when I do this grouping, so I'm going to do GCF again. And my greatest common factor this time is 2x plus 1. See, this has a 2x plus 1, and this has a 2x plus 1, leaving me with 4x squared minus 9. This is still a difference of 2 perfect squares. So I have to go 2x minus 3, 2x plus 3, 2x plus 1. It still equals 0 because I'm solving it. Now I take each one of these factors, set it equal to 0. 2x plus 1 equals 0, so x equals negative a half. 2x minus 3 equals 0, so x equals 3 halves. 2x plus 3 equals 0, so x equals negative 3 halves. See, what I did was I found out where this graph crosses the x-axis. Since it's a cube, we know a cubic function looks like this. And it's going to cross the x-axis 1, 2, 3 times. And here are my 3 places that it crosses the x-axis. Ooh, a table. I don't even have to read. Calculator. I go right to stat. Go to edit. I clear out my old lists. And I'm just going to enter my new ones. 1, 3, 5, 7, 9, 11. 1, 3, 5, 7, 9, and 11. Okay, my next list is 2, 25, 81, 175. Move this over here. 310 and 497. $310, $497. All right, so what do they want me to do? Write a power regression. Okay, so I'm going to come over here. I'm going to go into stat. I'm going to calculate. I go down to a power regression of list 1 and list 2. And where do they want to round my values to? 3 decimal places. All right, so y equals, make sure you write y equals because it says an equation, so it has to have an equal sign. 2.000 times x raised to the 2.298. Okay, use this equation to predict the bacteria's growth to the nearest integer after 15 minutes. Well, minutes is my x, so that means I'm going to put 15 in for x. So y equals 2.00 times x. Whoops, we're not going to use x, right? We're going to use 15. That's what they told me to put in for x. And then we're going to raise that to the 2.298. Now it's all calculator work. 2 times, oh, I messed up. And instead of deleting all this, you may have noticed right here, since I'm rushing, this is really 1. I rounded wrong. This is 1. I rounded wrong. Okay, so let's do this now. 2.001 times 15 to the 2.298. Y equals 1009, and we want to reduce it to the nearest integer. So that is my answer. Okay, last problem. Forces. Boom. As soon as I see forces, all I do is I draw 2 forces. Here's one. Here's the other. And we always put a resultant. One resultant. Sorry, one force is 25. The other force is 85. And acting on a body forming an angle of this whole angle is 55. All right, so we have to form a triangle. And once again, I'll say it every single time. We do not form the triangle by doing that. That is cutting off our resultant right here. We take our triangle and we extend our resultant and we create this top triangle. So, since this red line here and this force are parallel, we know this is also 85. We can get rid of this now. But we have a little bit of a problem. This is 55. This is going to be 125. Remember, these angles are supplementary because basically we were forming a parallelogram. And in a parallelogram, consecutive angles are supplementary. That's the trick to forces. Okay, so now they want me to find the magnitude of the resultant. So I wanted to find x here. And now we're back to trigonometry. Trigonometry says to find missing sides we use law of cosines or law of sines. And in this case, it's law of cosines. Remember, in the law of cosines, we find the angle and then the side across from it. And when we do the problem, they go across from each other in the problem. And then the other two the other two sides fill in our missing parts. Now, all we have to do is the math. So let's pull our calculator out here. 25 squared plus 85 squared minus 2 times 25 times 85 times the cosine of 125 gets me 1,287.69985, but that's what x squared is, so I'm going to take the square root of that. So x must be 101.4, and where do they want me to round to? To the nearest hundredth, so that's going to be 4.3. Now, what else do they want me to find? Find the measure of the nearest degree of the angle formed between the resultant and the larger force. Well, here's my larger force. Here's my resultant. So they're asking me to find this angle right here, which we'll call y. This one I'll do law of sines with. 25 is to the sine of y as 101.43, the resultant, is to the sine of 125. Sine 125 divided by 101.43. That gives me the sine of my angle that I'm looking for. So I have to inverse sine that. So that angle is a whopping 12 degrees.